that is how to achieve image classification with the help of deep learning, that is with the help of VGG-16 and with the help of deep learning. The previous session also we have seen this exercise, but this one we are going to the different session. That means how we can go and implement and achieve at last find the confusion matrix and evaluate the performance and so on. For this one, we are going to take the dataset from the previous one and online, and that means you are going to by GitHub. So this is the part 1 video. We are going to see the part how we can visualize the images. At the end of the session, that means part number 2, we are going to apply the CNN model and VGC model, VGC-16 model. Then we are going to check the test and test accuracy and validation accuracy. Once again run the model, at last predict the accuracy and so on with the help of confusion matrix formula. And before that we had now about this image classification. That means in this one particularly here we are going to use the GitHub cone where we are going to image collection set. Here by default there will be a 25,000 images available for training. That means on the end of the session, with the help of this project we can visualize and determine whether the given image is a dog or belongs to cat, like that. That is possible. The images will be trained well, and 12,500 images valid moved for testing process here. Here the step number 1, we are going to ask you to import the package like pandas, TensorFlow with the support of NumPy and print the version also, that is 2.17.1, and we are going to collect the dataset from GitHub. So we are doing git clone and giving the abbreviation, and it will definitely support for cloning the data from the remote area. And then we are going to pre-process, and here we are going to assume that image height 128 followed by the function called get path frame and followed by the file names if there are not, and list out everything with the problem of with the help of pd.data frame. After execute the line, we are going to check the few lines of the file. So we are going to write the line called ds equal to get underscore path frame image classification and dataset, like that. If we give the tail of I, it may approximately print the few lines of the data path, that is a dataset. Since I told you around 25,000 images are hidden here for training and 12,500 moved for testing here. And next we are going to load the data and pre-process the image with the help of the line called function called definition space load and pre-process underscore image. Then we are going to load the image and resize it to desired shape. So because later we are going to train with a data augmentation technique, with the help of data augmentation we can go for a rotation, flip and enhance and any other thing. You can do a number of operations. And so we are going to write the code called image equal to tf dot image resize of image comma image with followed by image height and return image, and we are going to convert the whatever the information convert to the tensor, because these are steps needed to get the information, because images won't be understood by the computer very easily. So we have to follow the step. And since if you are strong in CNN, this kind of project will be helpful for you. And we are going to set the path again, and we are use the uncut label where we are going to the category, and after this executing the code we are moved to the converter tensor. There will be shape of the xin data, that means shape of the yn data. So what are the images we are going to predict and visualize, everything should be follow some of the format, the input size as well as the output size. Then we are going to assign the data set where we are following the take of some information and execute it. Then we are going to visualize the images. For visualize some random images from the dataset, the clone dataset, we are writing the function called definition space plot images of image ls. Then we are checked out the figure and the image. We are writing the for loop, and we are writing the images ls equal to for n image in enumerator of x comma take of 5 and image ls dot up and up image. So at last plot images of images ls. So these kind of steps helpful to display randomly 5 images from the dataset. Since I told you it's a large dataset consists of 25,000 images. So randomly predict and randomly print the images like a dog, cat and so on and so on. So this is a part and video. I hope that you understand how we can implement image classification with the help of VG-16 and transfer learning for visualize the images and at last predict whether the given image is a cat or dog. Thank you for watching the video. Remaining will continue with the next session. If you like the video, please subscribe and share with your friends. Thank you.